Hello everyone, welcome back to Rosy Maths class. This is an introduction video of the chapter Rational Numbers. Let us see what all concepts we will learn in this chapter. We have already learned about natural numbers, whole numbers and integers. The counting numbers, that is 1, 2, 3, 4, 5 are called natural numbers. If you add a 0 to this set, it becomes the whole number set. When we include the negative numbers, this becomes integers. So integers is negative numbers, 0 and positive numbers. And when we include fractions like 3 by 2 minus 7 by 5, this whole set, integers and the whole set, is called rational numbers. The simplest definition of a rational number is a number which can be written in the p by q form, where p and q are integers and q is not equal to 0. So this is important to understand that p and q must be integers, numbers from this set. Okay, these dot means countless number on this side and this 3 dots here means number on the right side. So any number from this set we can take as p and q is not equal to 0, because if the denominator becomes 0, the number is undefined. That doesn't have any value. So q must not be equal to 0. Examples are minus 2 by 3, 6 by 7, 9 by minus 5, 0, minus 2. This is also rational number because this can be written as minus 2 by 1, 4 by 1. Next we will learn about the properties of rational numbers. The first property is closure property. Closure property means that when we add, subtract, multiply or divide any two rational numbers, do we get a rational number? Let us find out. Rational numbers are closed under addition, which means that when we add any two rational numbers, we will always get a rational number. 3 plus 2 is 5, so it's 5 by 7. It is also closed under subtraction. If you take any two rational numbers and subtract, you would always get a rational number. It is closed under multiplication. Any two rational numbers, when we multiply, we get a rational number. So rational numbers are closed under addition, subtraction and multiplication. What about division? Rational numbers are not closed under division. For example, 2 by 7 divided by 0. This is not defined, because any number divided by 0 is not defined. So this is not closed under division. Note that if we exclude 0, then it is closed under division. However, in general, it is not closed under division. The next property is commutative property. Here we will check that if we take any two rational numbers and we perform any of the four operations, will the answer change if we change the order of the numbers? First one, addition is commutative for rational numbers. That means if a and b are two rational numbers, a plus b is equal to b plus a. Changing the order will not change the sum. 2 by 5 plus 1 by 5, that's 3 by 5. And this side, write 1 by 5 first. So 1 by 5 plus 2 by 5, that's 3 by 5. Answer remains the same. Subtraction is not commutative. A minus b is not equal to b minus a. For example, 4 by 5 minus 1 by 5. This is 3 by 5. 4 minus 1 is 3. So that's 3 by 5. If you change the order, 1 by 5 minus 4 by 5. 1 minus 4 is minus 3 by 5. So we are getting different answer. That means subtraction is not commutative. Multiplication is commutative. A into b is equal to b into a. Even if you change the order, the product still remains the same. 2 by 21, 2 by 21. Division is not commutative. A divided by b is not equal to b divided by a. So I have taken this as a and this as b and have worked it out. So I got minus 35 by 12, and when I change the order, take this first, 3 by 7 divided by minus 5 by 4, I got this as the answer, which means that these two are different. So it is not commutative. So remember, addition and multiplication are commutative, subtraction and division not commutative. The next property is associative property. Just like commutative property, here also addition and multiplication is associative and subtraction and division is not associative. Let's see the examples. Here we will take three rational numbers. Let's say a, b, c are three rational numbers. So A plus B plus C is equal to A plus B plus C. So here first we add B and C, that is 2 by 7 plus 3 by 7 is 5 by 7 plus 1 by 7, that's 6 by 7. If you change the numbers in the bracket, so we will solve the bracket first. 1 plus 2 is 3. 3 by 7 plus 3 by 7 is 6 by 7. So we get the same sum, which means addition is associative. Subtraction is not associative. That means when we change the numbers in the bracket, we will not get the same difference. 4 by 9 minus 2 by 9 is 2 by 9, and when we do 8 minus 2, we get 6 by 9. Here, if I do 8 by 9 minus 4 by 9 first, I would get 4 by 9 minus 2 by 9 is 2 by 9. So different answers, so it is not associative. Multiplication is associative. A into B into C is equal to A into B into C. You can see this example here. If we multiply these, the product would still be same. So multiplication is associative. A divided by B divided by C is not equal to A divided by B divided by C. Here I have got A as 1 by 2, B as minus 1 by 3, C as 2 by 5. When I solve this, I get minus 6 by 10. And now if I change the place of the bracket, so I put 1 by 2 and minus 1 by 3 in the bracket, divided by 2 by 5 and solve it, I would get minus 15 by 4. So the answers are different. So division is not associative. Make a table like this for easy remembering. Here A is for addition, S is for subtraction, M for multiplication, and D is for division. And these are the three properties that we have discussed. So rational numbers are closed under addition, subtraction and multiplication. So I have put a tick for that. Addition and multiplication is commutative for rational numbers. Similarly, addition and multiplication is associative for rational numbers. The next is the distributive property. For all rational numbers A, B, C, A into B plus C is equal to multiply A to B and A to C, and whatever sign is there in between, just put that. Similarly, A into B minus C equals to AB minus AC. You can take A as minus 3 by 4, B as 2 by 3 and C as minus 5 by 6. Substitute in the left hand side and then on the right hand side and see if you get the same result. Next we have additive identity and multiplicative identity. 0 is the additive identity, which means that any rational number when added to 0 or 0 added to any rational number gives back the same rational number. 2 by 3 plus 0 is equal to 0 plus 2 by 3, which equals to 2 by 3. 1 is the multiplicative identity. Any rational number multiplied by 1 or 1 multiplied by any rational number gives back the same rational number. Next we have additive inverse, or also called negative of a number. Suppose A by B is a rational number, so minus A by B is the additive inverse. It is very simple, just change the sign. If this is positive, make it negative, and if this is the rational number minus A by B, which is negative, make it positive, A by B. And when we add the rational number and its additive inverse, we always get a 0. For example, 13 by 17. This is a positive rational number, so the additive inverse is minus 13 by 17. When we add these two numbers, we would get a 0. The next property is multiplicative inverse, which means reciprocal. For example, 8 by 21. Multiplicative inverse of 8 by 21 is 21 by 8. The denominator becomes the numerator and numerator becomes the denominator. So this basically means taking the reciprocal. And when we multiply these two numbers, we would get a 1. So any rational number multiplied by its multiplicative inverse gives 1. Note that 0 has no reciprocal. 0 has no reciprocal, and 1 and negative 1 are their own reciprocals. Because 1 can be written as 1 by 1, which is nothing but 1, and negative 1 is equal to negative 1 by 1 or negative 1. So 1 and negative 1 are their own reciprocals. Representation of rational numbers on the number line. This is same as we have learned about fractions, how we represent fractions on the number line. Same way we can do the rational numbers. So 1 by 3 lies between 0 and 1. Draw a line and label 0, 1. The denominator is 3. So divide into 3 equal parts. 1, 2, 3. 1 by 3 would be first part. This is 1 by 3, this is 2 by 3, and this is 3 by 3. If you want to represent minus 7 by 4, there is a minus sign. So this is to the left side of the 0. Again draw a number line and see the denominator. It is 4, which means between 0 to minus 1 there would be 4 equal parts. Again from minus 1 to minus 2, 4 equal parts. And then we need to represent minus 7 by 4 on this line. So this is 0, this is minus 1 by 4, 0, minus 1 by 4, minus 2 by 4, minus 3 by 4, this is minus 4 by 4, minus 5 by 4, minus 6 by 4, minus 7 by 4. So this is the required point, and here this is the required point. And the last subtopic of this chapter is to find rational numbers between any two rational numbers. Well, there are countless rational numbers between any two rational numbers, infinitely many rational numbers. There are two ways in which we can find out the rational numbers. First one is by making the denominator same, and the second method is by finding the mean. Let's see the first method. To find 10 rational numbers between minus 5 by 6 and 5 by 8, and we want to do this by making the denominator same. So first convert minus 5 by 6 and 5 by 8 to rational numbers with the same denominator. Take the LCM of 6 and 8. So 2 3s are 6, 2 4s are 8. Multiply all these 3, you would get the LCM, which is 24. Now convert this 6 to 24. So multiply by 4. Since you are multiplying in the denominator, you have to do it to the numerator also. So this becomes minus 20 by 24. And similarly 5 by 8. We want the denominator to be 24. So multiply 8 by 3 and again the numerator by 3. So that's 15 by 24. So the new rational numbers that we have got is minus 20 by 24 and 15 by 24. Now between these two rational numbers, we have minus 19 by 24, minus 18 by 24, minus 17 by 24, so on till 14 by 24. All these rational numbers are between these two rational numbers. So you can take any 10 out of these. This is the first method of finding the rational numbers between any two rational number. The second method is by finding the mean. Let us see an example. Find a rational number between 1 by 4 and 1 by 2. So first find the mean. So if this is A and this is B, A plus B by 2 will give us the mean. So 1 by 4 plus 1 by 2 divided by 2. 1 by 2 can be written as 2 by 4. 1 plus 2 is 3. So 3 by 4 divided by 2. So 3 by 4 into 1 by 2, that equals to 3 by 8. So 3 by 8 lies between 1 by 4 and 1 by 2. If you want to find a rational number between these two numbers, again follow the same steps. Add these two, divide by 2. I feel this method is a bit lengthy. So what you can do is you can go for the first method, wherein you have to convert it into the same denominator, and at one go you will find so many rational numbers between any two rational number. So with this we have completed all the concepts given in this topic. I hope you find this video helpful. Thank you.